Hello, everyone. I am Babak Rasmi. I'm a research fellow in mathematics and statistics discipline. Today, we want to have a short talk related to optimization and operations research and their applications in industry. In this presentation, we want to cover and show how operations research and optimization work for industrial problems. I will give you two simple examples to show you the main components and the main structure of operations research and optimization in order to model different problems. And after that, I will share a couple of experiences related to my PhD and my current work at Curtin University with you in transportation and workforce rostering. Every day we are dealing with different decision problems. For example, for a student, you like to optimize everything, optimize the outcome of your efforts. You want to do something to have actually fun at the same time and do your workout, do your studies, and see the best outcome at the end. So this is very important to have a right schedule. The same thing happens for different businesses and companies. They try to consider all of the limitations, all of the operational limits, and find the best solution for their businesses. This is very important for these companies to maximize their total profit. So mathematical models are very important and useful in order to model these problems and find the best solution or optimal solution in order to have the best outcome at the end. I want to show you three main components of the mathematical models. The first one is decision variable. Decision variables are the things you want to decide about. You want to find the optimal level for those variables. For example, for a manufacturer, it is important to know how many products should be produced every month in, for example, next 6 months or next 12 months. Or they need to know how many workers or operators are required in order to complete all of their activities. So based on that, these kind of decisions can be presented by decision variables in mathematical models. The second component is objective function. Objective function is the main thing you want to optimize. And most of the time, your objective function is a function of decision variables. For example, in a company, maximizing the total profit can be the main objective function, or minimizing the total cost, or minimizing the total delay for a delivery person is very important, or maximizing customer satisfaction in service systems are very important for these kind of companies. The third component is constraints. Constraints are some formulations that can be formulated using equality or inequality constraints, using decision variables and other parameters altogether. For example, in different companies, you have different limits. So if you want to have a feasible solution at the end, you need to have some constraints related to your limits, for example, a budget limit, time limit, or operational limits. Otherwise, at the end, you will have an infeasible solution that is not acceptable for you. I showed you three main components related to operations research and optimization. Now, I want to give you an example to see all of these components all together. Please assume that we have a flexible metal rod, and the length of that is 200 centimeters or 2 meters. We want to bend the corners in order to reshape that to a rectangle. And we want to have the maximum surface area for that rectangle. So here, we need some decision variables for our problem. What are those decision variables? The main decision variables here are the width and length of this rectangle. So we have two decision variables here, L and W. And consequently, objective function would be the product of these two decision variables, L times W. And our constraints are like this, because the length of our rod is limited. So 2L plus 2W cannot exceed 200 centimeters. And moreover, our decision variables are non-negative, so they should be something positive. Otherwise, they wouldn't be meaningful. So here you can see we have two decision variables, and we have a couple of constraints, and you can see the objective function in order to minimize the surface area. In the second example, I want to show you something a little bit complex comparing to the previous one. In applied math and industrial engineering, routing a vehicle is very important. What does it mean? It means that on a map, we have a location. We want to start from this location. We want to visit multiple other locations and return to the first point. Here, what is the best order of locations to be visited in order to have the minimum total traveling distance or minimum total distance? So the combination of these locations or the order we need to visit them is very important to have the minimum traveling time. So in this example, we are looking for the best route. And one of the first solution methods you can apply is brute force. You can simply count all of the solutions and make a comparison between them. For example, if we have 5 locations, in total we will have 120 combinations or different orders in order to visit the locations. That's why you can calculate the traveling time related to each of these combinations, and at the end make a comparison between them and report the best one to your manager. It is very simple and straightforward. But if we have 10 locations to visit, in that case, the number of combinations would be more than 3 million. In that case, still you can write a Python code, Java code, use some programming languages in order to calculate all of those combinations, traveling times, and make a comparison and report the best solution. But if we have 100 locations, is it practical or not? Definitely not, because if you want to follow the same solution method, I mean brute force, in that case, you need to spend more than 10 to the power of 150 years in order to find your solution, find the optimal solution. So this is not practical at all. In that case, we can use mathematical models. We can model these kind of problems using a simple trick with a decision variable like xij, which is a binary decision variable that takes value of 1 when we need to visit location j immediately after I. And based on that, we can model the problem and solve it only in a few seconds and find the best solution for our problem. This is the importance of operations research and optimization in order to find very effective solutions for these kind of problems. Now, I want to share a couple of experiences related to the previous projects I have done and show you how optimization can work for different industrial problems. This is the map of Istanbul. During my PhD, I was working on a project in order to distribute spare parts for an appliance. Istanbul is a huge city with more than 20 million population. So distribution in a very crowded city is very challenging, and you need to be very effective in your distribution plan. In that case, we had more than 90 retailers in the European side of Istanbul for this appliance manufacturer, and more than 60 retailers on the Asian side. So more than 150 retailers in Istanbul. And we had a depot in this corner, you can see, and every day each retailer was submitting a different order, and we had to fulfill all of those orders within a specific time window. That's why the problem was huge and very challenging. So each customer orders different things every day, and we need to deliver all of them within this time window from 8 to 11 a.m. We use optimization models and algorithms in order to find out what are the orders that should be batched together and put in a specific truck. What is the best route for each truck in order to deliver the orders within that time window? And in order to answer all of these questions, we used optimization algorithms, and we could reduce the total cost for that distribution more than 12%, which was a very significant improvement. In the second application, currently we are working on optimization models in order to optimize workforce rostering for construction companies. In construction companies, most of the time they have some long-term projects, for example, in 6 months or 12 months. In each day, they need different requirements in order to complete their activities related to that specific day. It means that here, you can see that on different days, we have different workloads. And we have different, job requirements. What does it mean? For example, on this specific day, the company needs to operate 3 excavators. That's why they will need at least 3 operators with right set of skills in order to operate those excavators. On another day, they need to operate 2 excavators plus 5 bulldozers. So that's why they will need at least 7 operators with right set of skills in order to operate 2 excavators and 5 bulldozers. So the point is that we have different workloads on different days. And moreover, each specific operator needs a specific schedule. It means that they need to know when to start their job, when to leave their job, and most of the time these workers are fly-in, fly-out workers. That's why we have to have a right roster for each of them in order to give them off and on times and hire them at the right time and the right place, in order to give them right job. Otherwise, they can be idle, or we need to do extra payments to the workers in order to pay their salaries. However, they are idle in different days. So for these operators, using optimization algorithms and a heuristic method, we could understand when is the best time in order to hire each worker with the right set of skills, and what are the rostering plans for each of them in order to have off and on times. And based on that, we could minimize the total payments in terms of salary to different workers and have the right number of workers on the right days. We have a lot of industrial collaborations at our department. The areas we are working on is related to mainly logistics, mining, oil and gas, and we have worked with different companies. I'm happy that I could explain a couple of them to you today. And if you have any question, I would be happy to answer. And later on, if you would like to ask further discussions, you can contact me with this email. Thank you very much.